All right, analyzing quadratic equations or functions. So when we analyze a quadratic function, that means relating the actual function to a real life problem. And we're going to do a little bit of both, using the information that we know about characteristics of the function plus finding these values on our calculators, okay? So it's a little bit of a combination of both. So the first example, it says the equation shows the height of a soccer ball, h of d meters, as a function of the horizontal distance d the ball travels until it first hits the ground. And here's our function. H of d is equal to negative 0.025 times d minus 20 squared plus 10. So sketch the graph, be sure to label your axes. So going back and reading the question, we're talking about the height of the soccer ball in relationship to the horizontal distance. So this is the distance the ball has traveled in meters versus the height of the ball in meters. And so because my a value is negative and it's a fairly small a value, the graph I know is going to take some kind of shape like this. Right? We're kicking the soccer ball from the ground, so it's going to leave the ground here, and then it's going to travel in the air and then hit the ground again at some point over here. First question, what is the maximum height of the ball? Well, looking at my graph, the maximum height is going to occur at the vertex of my graph. And looking at my equation, this is written in vertex form. So remember, my vertex is always my p comma q values. So the vertex of this graph would be 20 comma 10. 20 relates to the horizontal distance of the ball. 10 would relate to the vertical height of the ball. So the maximum height of the ball is going to be 10 meters. What is the horizontal distance of the ball from the kicker when it reaches its maximum height? Well, that is going to relate to the horizontal distance of my vertex. So the horizontal distance would be 20 meters. How far does the ball travel horizontally from when it is kicked until it hits the ground? Well, because we know all quadratic functions are symmetrical, if the ball is leaving here at 0, 0, at a distance of 0 and a height of 0, and it reaches this point at 20 meters, it is going to hit the ground also at 40 meters. So how far does the ball travel horizontally? So just knowing characteristics of our quadratic and knowing that quadratics are all symmetrical about that vertex or about the axis of symmetry, we know that this point is going to be 40 meters. What is the height of the ball when it is 10 meters horizontally from the kicker? Okay, so this is a little trickier. So now we want to figure out this horizontal, we know this horizontal distance is 10, and we want to figure out the height of this ball. So we're trying to figure out this height. Okay, two ways to do this. You could substitute the 10 into your quadratic function. So we know our horizontal distance is 10. So we'd go 10 minus 20 squared plus 10. So on our calculators, right, if we substituted that in, negative 0.25 bracket 10 minus 20 squared plus 10. So my answer would be, that does not seem right. Oh, it's negative 0.25. Negative 0.025, 10 minus 20, all squared, plus 10. There we go, that looks better. So the height of the ball would be 7.5 meters. Okay, or you could type this into your calculator, the function into your calculator, go to your y equals, type the equation in, negative 0.025, x minus 20, all squared, plus 10. Graph this. Before you graph it, think about your window setting. X is our horizontal distance of the ball. Well, there's no such thing as negative horizontal distance. So I'm going to start this at -2 just so that I can see the axes. The maximum distance my ball reaches is 40, so I'm going to go a little bit past that, 45. I'm going to again start this at a -2 for my height, and the maximum distance of my ball was 10, so I'm going to go a little bit past that as well, maybe to 12. So now I'm going to graph this. All right, so here's the shape or the path of my ball. I want to find the height when my distance is 10. So if you press second trace on your calculator, the screen comes up and you can go to question number 1 for value. Here you can type in any x value that you want that relates to your function. And in this case, I want to type in my horizontal distance of 10. Hit enter and then it gives you your height. Okay? So that would be a second way of finding that value. The first one would be algebraically, this one would be graphically. And these types of questions, it is your choice how you do that. I encourage graphically if you can, and then in the future when we get into more algebraic processes, you'll do it algebraically then. Okay, last question. When an opposing player positioned under the path of the ball 34 meters from the kicker be able to head the ball? Okay, so this is similar, kind of similar to the same question. We basically have to figure out, well, how high is the ball at that 34-meter mark? Okay, and so since I already have this in my calculator, this would be the most efficient way to do it. So I'm going to go second trace again. I'm going to go to number 1, but I'm going to type in a distance of 34 meters. And I get a height of 5.1 meters. So the height of the ball would be 5.1 meters. So if an opposing player was underneath the ball at this point in time, I would say they would not be able to head that ball because there's no way anyone would be able to jump 5.1 meters high in order to actually head the ball. So the answer is no. The height of the ball is too high.